All right, so Chapter 5, Lesson 8 is Factor Linear Expressions. Problem 1 says here, a rectangular yard is being separated into 4 equal-sized sections for different items at a yard sale. The area of the yard, the total yard, is 8x plus 12 square meters. We want to see how can we find the area of each section of the yard sale. So all you have to do is take the entire yard and divide it into 4 equal sections. So here we have, all we have to do is divide the 8x plus 12 by 4. Now, I'm going to show you how to do that. So here, if we have the 8x plus 12, and we divide that by 4, you're going to divide each term by 4. Oops. You're going to divide each term by 4. Okay? So when you simplify that, 8x divided by 4 is 2x. Very good. Plus 12 divided by 4 is 3. Now, when you finish writing this, you're going to put what you divided by on the outside because we divided it out. In other words, we factored it out of the expression, right? We factored it out. So factoring it out and dividing are the same thing. So here, that's going to go on the outside of the parentheses. So 8x plus 12 is equal to 4 times the quantity 2x plus 3. Now, you'll notice here that if we used our distributive property and put that 4, distributed the 4 back into the parentheses, what are we going to end up with? We're going to end up with 8x plus 12. So, in order for us to factor a number out, we need to find the greatest common factor. So here we're going to find the greatest common factor of monomials. Please make sure you write down the definition of a monomial. A monomial is a number, a variable, or a product of a number and one or more variables. All right, so please make sure you write down the definition of a monomial. These are examples of a monomial. Here, there's a number, 25. That is a monomial. Mono means 1, right? Mono means 1. X, there's the variable. Or a product of a number and one or more variables. So here, this is 40x. That is also a monomial. If I had 40xy, that would still be a monomial because it's all multiplication. Now here, these are not monomials. These are 2 separate terms, okay? A monomial, if you look at the monomials, it's all multiplication. Does everybody see that? Over here, where for the non-examples, they are separated, their terms separated by an operation. So those are not monomials. If you have an addition or subtraction in there, it is not a monomial. You got it? All right. To factor a number means to write it as a product of its factors. A monomial can be factored using the same method you would use to factor a number. The greatest common factor of 2 monomials is the greatest monomial that is a factor of both. Now, I'm sure that you remember way back when we were finding greatest common factors and we used factor trees. All right, so for examples 1, 2, and 3, we have 4x and 12x. We want to find the greatest common factor of each of the terms. So here we have 4x. Now 4x, the prime factors are 2, 2, and x. So 2 times 2 times x gives me 4x. For 12x, that's 2 times 2 times 3 times x. To find the GCF, you're going to circle the factors that they have in common and then multiply them. So here we have in common the 2's, those 2's, and those 2's, and those x's. And that 3, of course, doesn't pair up to anything in the 4x, so that just gets left alone. So the greatest common factor is found by multiplying 2 times 2 times x. So the greatest common factor of 4x and 12x is 4x. For 18a and 20ab, so here 18a can be broken into 2 times 3 times 3 times a. 20ab is 2 times 2 times 5 times a times b. When we circle what they have in common, you'll see that the only things that they have in common are the 2's and the a's. So we multiply that 2 times a to get 2a. So the GCF of 18a and 20ab is 2a. Okay? And the same thing with example 3. You break it into its prime factors. Both terms, both monomials break into their prime factors. Circle what we have in common and multiply them together. So here, 2 times 2 times 3 times c times d. That's going to give me 12cd. All right, so we want to find the GCF of each pair of monomials. And remember, we can use factor trees to help us if we can't remember, if we can't figure out the prime factorizations, okay? So 12, if I have 12, that can be broken down to 4 times 3, right? And then this can be broken down to 2 times 2, and then we're going to bring down the 3. So our prime factors for 12 are 2 times 2 times 3. For 28, when we break those down, we can do 4 times 7. And of course, the 4's get broken down to 2 times 2, and then we bring down the 7. So now, oh yes, and there's a C there too. So this is 28C, thank you. So I should have brought down the C here, and then brought down the C there. You got it? So the prime factors are 2 times 2 times 7 times C. You guys remember I like to leave space when there's nothing in common there. So now we're going to circle what they have in common. So we have 2's here, 2's there, and anything else? No, that's it. So the GCF we find by multiplying the 2 times 2, which is equal to 4. So the GCF of 12 and 28C is 4. Okay? Now, sometimes you can find the prime factorizations without using the factor trees. So here, for 25x, that's an easy one, right? This is going to be equal to 5 times 5 times x. Very good. And then, so for 15xy, that's going to be 3 times 5 times x times y. Okay? And now we can circle what they have in common. So here we have the 5's in common. Anything else? And the x's in common. Very good. So the GCF is what? 5 times x, which is 5x. Very good. So sometimes you don't need to do the factor trees. All right. So here, I was able to do the 14mn without doing the factor tree. I used the factor tree to do 42mn to factor those out. I ended up for the 42mn, 2 times 3 times 7 times m times n. And then for 14mn, I got 2 times 7 times m times n. And then I circled what they have in common. So we get 2 times 7 times m times n, which is 14mn. All right, so now we're going to factor linear expressions. So you can use the distributive property and the work backwards strategy to express a linear expression as a product of its factors. A linear expression is in factored form when it is expressed as the product of its factors. Please make sure you write that down. So for example, we have 8x plus 4y. When I can factor, if I factor out the a 4 from both of those, because the GCF of 8x and 4y is 4, and I divide that out, then I'm going to have 4 times 2x plus 4 times y. So here, the backward strategy, if you look at this, means that I'm going to take this 4 and I'm going to undistribute it. Is everybody with me? So I'm going to take the 4 out and I'm going to put it in front of the parentheses. You see that? In front of the parentheses. And then what's left, 2x plus y, stays in the parentheses. In the examples, for example 4 and 5, here we want to factor 3x plus 9. So the first thing we want to do is we want to find out what the GCF is. What can we divide into out of both of those, okay? So what can we take out of both of those evenly? So 3x we can break down to 3 times x. And of course 9 can be broken down to 3 times 3. So the GCF is 3. So I'm going to divide 3 into both terms. Does everybody see how I'm showing the work right here? So here I've got the 3x plus 9, and just like we did in the warm-up, I'm going to divide 3, I'm going to divide by the GCF in both terms. So the 3x divided by 3, those 3's cancel, and what am I left with? I'm left with x. You see that? And then here, 9 divided by 3 is 3. And then the number that we divided by, the GCF, goes on the outside of the parentheses. So here, for example 5, it says 12x plus 7y. It says, first thing we want to do is we want to find the GCF. Well, when I do the factors, when I find the prime factors for 12x, we have 2 times 2 times 3 times x. The prime factors for 7y is, we don't even really have to write the 1, 7 times y. So, because, did everybody see we cannot circle any common factors here. So because there are no common factors, 12x plus 7y cannot be factored. It's in its simplest form. So here it says factor each expression. If the expression cannot be factored, write that it cannot be factored. Now, the first thing we're going to ask ourselves is, what can I divide out of the 4x and the 28 evenly? I can do better than 2. 4, right? So we're going to divide both terms by 4. Okay? You're going to divide both terms by 4. That number that we're dividing by goes on the outside of the parentheses. So the 4 goes on the outside of the parentheses, and what's left after we divide stays inside the parentheses. So 4x divided by 4 is 1x, or just x, minus 28, so negative 28 divided by 4 is negative 7. So that's x minus 7. So 4 times the quantity, x minus 7, is the factored form of 4x minus 28. For example E, we've got 3x plus 33y. Now, looking at those two terms, we don't have to do a factor tree to figure out what the GCF is, right? Yeah. What's the GCF of 3x and 33? 3. Very good. So we are going to divide both terms by 3. Okay? And that 3 is going to go on the outside of the parentheses. Okay? So 3 goes on the outside of the parentheses, and what is left over after we're dividing goes on the inside of the parentheses. So 3x divided by 3 is x, and then a positive 33y divided by 3 gives me a positive 11y. Very good. And there is your factored form. Example F says 4x, we want to factor 4x plus 35. Now, what can I factor out? What is the GCF of 4x and 35? Nothing. You cannot factor anything out of there. So here, this is already in simplest form. It cannot be factored. So down here, you're just going to write cannot be factored. All right, so example 6 says the drawing of a garden at the right, well, down below, has a total area 15x plus 18 square feet. Find the possible dimensions of the garden. Now remember, when we're looking for possible dimensions, we're looking for length times width. So we want to know what number can we multiply times the other. So here, in order to do that, we are going to find the GCF and factor it out. So that GCF will be either the length or the width, and then what's left will be the other. Okay? So here, what is the GCF of 15x and 18? 3. So that is what we're going to divide both terms by. So we're going to divide both terms by 3. That number goes on the outside of the parentheses, and what's left goes on the inside. So here we have 3 times 5x times a quantity, 5x plus 6. So here, that tells me that, let's see, we could say that 3 is the length and 5x plus 6 is the width.